Good morning, everybody. Um, Today we have round 773. It is a Div 1 round, so I don't, so I'm going to be focusing more on like solving the problems and probably spend less time like saying my thought process out loud. But if you're competing, good luck. I don't need to do that. Be number of binary decimal if it's positive. Smallest number of binary decimals. I think we can probably just greedy, right? Yeah, greedy would make the most sense because we could just do like where I is equal to 2, I is less than, I guess 9, right? Because then it's 2 digits. I'll do long just to be safe. 1L long boo. So we first multiply by 10. If I mod 2 is equal to 1, then we plus 1. Then temp is equal to max of temp in x. Yeah, so res increases by this much and subtracts by temp. Oh wait, I'm stupid. I misread this problem completely. Ah, shoot. How do we do this then? It's just the maximum digit. Okay. And res is equal to 0, so while n is greater than 0, res equals max of res and n mod 10. And then you divide n by 10. There we go. Yeah, I was just being stupid. 251. Alright, let's submit A. Oh my god. Codeforces just crashed for me. Awesome. Problem A. Submit. Is there a Q right now? That would suck. Whatever. I'll look at B. To celebrate your birthday, you have prepared a festive table. Now you want to see as many guests as possible. Table can be presented as a rectangle with height h and w, and width w divided into h by w cells. We let ij denote the cell in the ith row in the jth column of the rectangle. Into each cell of the table, you can either put a plate or keep it empty at each guest. You can only put plates on the edges of a table into the first or the last row of a rectangle. And then, like what? Oh, okay, I see. No two plates that you can put into cells that have a common side or a corner. So if cell ij contains a plate, you can't put plates into cells. Here, 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 here. Okay, so it's all 8 adjacent places. Okay. Put as many plates onto the table as possible without violating these rules. Each thing is at most 20. Oh, we have to output the configuration. Okay, well if we put a plate over here, it blocks these cells. But if we put a plate over here, then it only blocks these cells. Yeah, so we want to always put a plate in this corner first. What would bitmass.dp look like? I don't think it's viable, but if each side is at most 20, then it's like, yeah, it's too much. If we do this, I wonder if we can just greedy then. We probably could. Let's try. Or wait. Why would greedy not work? Actually, no, I think greedy should work. We'll give it a shot. Okay, and then H. No, there we go. -1, 1, 0, 0. And dy. Okay, so it's 0, 0, 1, -1. We do 1, -1, 1, -1. Are these all 8 directions? Seems like it. Okay, so then it's like if r plus dx at d is okay, well if the min of or dy, c plus dy at d, if it's greater than 0 and r plus dx at d is less than n and c plus dy at d is less than m, res at r and c. If sum is equal to 0, res at rc is equal to 1. Why is this happening? c is equal to 1, do we have 0 and -1? We do. 1, 2, 3, 4, 5, 6, 7, 8. dy at d, dy at d. Oh. R plus dx at d. D plus dy at d. I think this is correct. 1, 2, 3, 4, 5. There's 8 cells in here. There's 9 cells in there. How many plates do we have to put? As many plates as possible. Wait, so there's only 8 plates over here, but in here I found a way with 9. Does this violate the configuration? Like if there's... Oh wait, plates can only be on the edge of a table. I forgot about that. Hold on. Okay, so if r is greater than 0 and r plus 1 is less than n, and c is greater than 0, and c plus 1 is less than n. So if it's, yeah. Let's see. That makes a little bit more sense. I'll try to submit it. Okay, we got B. We will move on to problem C. A contestant can get between 0 and 100 points, inclusive, for each stage independently of other contestants. What does that mean? Points received by contestants in different stages are used for forming overall results. We suppose that k stages of a contest are completed. For each contestant, k minus k over 4. Stages with the highest score are selected. And these scores are added up. So we assume 9 stages are completed and your scores are these. First 7 stages, highest scores are chosen. Because it's 9 minus 9 over 4, which is 2. Yep. And then you sum all of them together. You get 430. Okay. What is the smallest number of additional stages after which your result might be greater? Let's see. Okay, so in the worst possible case, you got all zeros and Ela got all hundreds. Then in order to tie, you have to do at most n more moves. Or you get 100 and then Ela gets 0. So you only have to add on at most n extra things. So we can just simulate this. Yeah, int array. Q opponent equals new priority Q. Everything is at most 100, so we can use integers. Sum1 is equal to 0 and sum2 is equal. Okay, well. Active.add x. Hold up, opponent. How do I do this? Okay, well, K is like how many things we want. So it's like, we've completed n stages so far. So we want n minus n over 4. Okay, then it's like active.poll. Yeah, it's like someone active.poll. So while opponent.size is strictly greater than k, then opponent.poll. Okay, so int res is equal to 0. So while sum at 1 might be greater than or equal to. Okay, while sum at 1 is less than sum at 2. Yeah, and so then it's like, while sum of 1 plus 100 minus active.poll active.add 100 and sum of 2 plus equal to, well, minus equal to opponent.poll, and then opponent.add at 0, and then we use a move like this. Oh, n does change. N changes. Okay. Wait, active.add opponent.add 0. Let me do this. Sum 1 plus equal to 100. K becomes n plus plus, and then k becomes n minus n over 4, and so while this happens, we do this. Why is this happening? Div.1+Div.2. Third test case is this. What is wrong with my implementation? 420 after 3 additional rounds. 7 minus 7 over 4 is 6. So it could equal to 420. Well, your result is 400. Yeah, why doesn't this work? Let's see. What's wrong with this? Got 2. $320 and 300. Do we keep them? Oh, maybe because we pulled them too early. That would actually make sense if that happened. Okay, how do we do this instead then? X150 C2. Because we know there shouldn't be that many moves anyway. Maybe just use binary search. Yeah, because even in the worst case scenario, if you have like n of number of these, it should be like at most 2n in total anyway. Let's try that. Like 2 times n plus, I'll do like plus 69, whatever. And then our final answer should be this. So if I is less than n, then we do this, otherwise we add 100. Then we skip the k lowest. Or like, no, we only take the k highest. I is equal to k, I is less than mid. Wait, no, we leave out this. We take k highest, so we want to leave out mid minus k. Yeah, so you start out at leave out. And then the same thing over here. Except now we add 0. Collections of sort ls and sum 2 is equal to 0. And then it's the same thing over here, except we do sum 2. So if sum 1 is still less than sum 2, O equals mid plus 1, else I equals mid. try this. I had another error. What is going on? Okay, at least we got C. 2-second time limit, that's fine. Alright, now we move on to problem D. Every December, VK traditionally holds an event. And employees numbered from 1 to n take part in an event. Each employee I is assigned a different employee B at I, to which employee I has to make a New Year's gift. Each employee I is assigned to a different employee B at I, to which employee I has to make a New Year's gift. Okay. Each employee is assigned to exactly one other employee. Nobody is assigned to themselves, but 2 employees may be assigned to each other. Okay. Each employee is assigned to exactly one other employee. Wait, so if this distinct integers, then it's a permutation, right? Employee I says I want to make a wish to employee A and I. They wish to make a gift. I want to maximize these wishes that are made. Okay, let's see. Yeah, I'll open up E so that I have it loaded. Well, this decomposes into cycles. And a wish is satisfied if it's a part of a cycle. So we have a cycle of wishes. That's who they want to give a gift to. If I want to give a gift to this person, then I'll make it 0 index. So in this example, they wish to, okay, employee 1 wants to give a gift to 6. Employee 2 wants to give something to 4. Employee 3 wants to give something to 6. Employee 4 wants to give something to 2. Employee 4 wants to give something to employee 2. And then employee 5 wants to give something to employee 4. Employee 6 wants to give to employee 5. And employee 7 wants a gift to employee 6. How do we do this? Only one of these wishes can be satisfied. Yeah, so like for every wish that goes into something, that wish has to be satisfied. Okay, so what if we satisfy each other's wishes up here? This wish is satisfied, and then this wish is satisfied. That's one way we could do it. Well, if we do this, and this forms a cycle. Okay. There's almost n wishes, so I mean, it's possible it's not connected. If it's not connected, then what do we do? Yeah, so what if we have like some big cycle like this? But this person wants to assign something to here. And all it does is disrupt the cycle. So for a cycle that goes around like this, then we can satisfy this many. we have like wishes that give them to each other like this, then it's fine. I think we could change this to, yeah, we make this so that it's a minimum number of edges we would need to add, such that it's basically a functional graph. Wait, because in a permutation graph, there's exactly one edge going in, and then from that there's exactly, so this is in and out. So we have to figure out how to reconnect a minimum number of edges such that the in degree and out degree are all one. Minimum number of edges we would need to change. We need to change these three over here. And here, well, 1, 2, 3, 4, 5. Let's say we had an edge going like this. Then we would need to change wait, no, the graph that we're given. Yeah, so if it's like a chain like this point's here, this point's here, this point's here, this point's here. No, for some reason we want to go here instead. This initial graph we're given already has all out degree. Yeah, so we're just pivoting edges away from things. So what if we just we pick out all of these extra edges. And you pick out enough edges. Six gives a gift of 5, which gives a gift of 4. 4 gives a gift of 2, 2 gives a 4. One gives to 7, 7 gives. Oh, we can't do this though. So it's like 3, 6, 5, 4, 2. We can't ever give a gift back to someone that already got a gift. So maybe it's just top sort. Like we draw a graph based on here. I mean, if there's a cycle already. Yeah, if it's already a permutation, then it doesn't really make sense. Digital graph already has up tops. Already has all out degree greater than 1. Yeah, so there's at most one edge going out of it. We just want to change the minimum number of edges such that all edges also have an in degree of 1. Or all nodes. Right, let's say we isolate these two. 1, 2, 3, 4, 5, 6, 7 gifts happening. Everyone should get a gift. Everyone should give a gift. 6 gives to 5. 5 gives to 4. Who's giving to 7 then? We can't just direct both of these over here, because what if there's like 1, 2, 3, 4, 5. Oh, 4 is getting an extra gift. So you have to put it like this. Wait, what if instead we delete this edge? Then we could direct back to 4 in here. Okay, what if we give a gift to 6? Then we give a 3 to 6. No, but there's already one extra. We give a 7 to 6. Then we 3 and 1 we have to change. And then we go 6 gives to 5, gives to 4, 5 gives to 4, 4 gives to 2. We have to change the 2 to 4 as well. This edge over here. And how do we change this? Maybe it's just like what if there's only one edge that's broken? I mean, if only one edge is broken, then we just like reconnect the cycle. 2 to 4. Does this always work? One to 3. Okay, so 2 has to give a gift, 7 has to receive a gift. These have to gift and receive. Yeah, because like for every chain, there's a place that it ends. Yeah, because if there's a conflict in here, it doesn't really matter if we take these edges anyway. It should, the way we connect the cycles, it should be the same anyway. Yeah, I think that's why this works. What about 1, 2, 1, just to make sure. Okay, 1 wants to give something to 2, 2 wants to give something to 1, 3 wants to give something to 2. So we assume 3 gives to 2, and we assume 2 gives to 1. Yeah, and we can complete the cycle. How do we do this then? What if we just add these edges manually? Will that work? Like we just go 1, you go, then we add on the edge to 2, then we add on the edge to 3, but 3 is broken. So we can't do that. We add on the edge to 4, which is fine. We add on the edge to 5, which we cannot do. We add on the edge to 6, which is okay. And we add on the edge to 7, which is not okay. So we just form something between 3, 5, and 7. That might work as well. Let's see. Int new int n int out degree is equal to new int n. Okay, so int b is equal to array a. Basically, okay, so if, okay, well clearly everything already has an out degree of 1. So if the in degree of b is equal to 0, else in degree we add these. Okay, so we need to change, in this case, 3, 5, and 7. 5 has a gift. You know, like we need to change the person that it gives it to. 7 has a gift. Who has not received the gift yet? Or no, we assume everyone, these are people that need to give, that need to change the person they give it to. So if we do 3, 5, and 7, the important edges are here, here, 3, 4, 5 is not important, 6 is important because the person who gives it to doesn't have a gift yet. Okay, so we need to change 5, who already has a gift. Who's already receiving a gift, I mean. Oh, okay, the integrity of 1 is equal to 0. I see. For an x, and we can change, if the integrity of x is equal to 0, then we want to shift add x, else have gift add x. And so index is equal to 0 for, okay, if I'm right, then the number of things should work. Else, add at a is equal to true. Then we do this. Okay, so if I is not bad, then we do some stuff. I is not bad, but the integrity is equal to 0. Then what we do is, yeah, 5 has received a gift. Has gift dot get index plus plus. Yeah, so we change our, like, all array at all, okay, array at a gives a new gift to I. Yeah. Okay, then we handle the cyclic shift stuff. Is there ever only one person? That's isolated. Yeah, what if 1 was already gifting to 7? Like, we had something that's like 1 to 7, then it'd be something like this, where, I mean, well, if it was that case, then 3 to 6 could already give something. Oh, what if it's like this? Like, we could take everything in here, or like, yeah, what if it was like 1 goes to 2, 3 goes to 4, 5, and then we have a double edge like this. So, okay, 1 could give something to 2, 2 can give something to 4, 3 cannot give to 2, 4 can give to 5, 5 can give to 6, but 6 cannot give to 5. Yeah, so now you're just kind of left out. Because 6 needs a give to 1. And then 3 needs a change. But 3 can't gift to himself, though. Is that at least 2? Okay. If n is at least 2... Yeah, so what if we did 1 gives a 2, 2 gives a 1, but now 3 doesn't have anywhere to go. Wait, in that case we could just delete, because 2 is already part of a valid cycle, we can just say we add in 3 to here. The number of edges we gain doesn't change. Yeah, and so whoever used to give the gift to 1 now has to give it to that. Okay, that's not too bad of a fix. Yeah. Okay, so if shift dot size is at least 2, else if shift dot size is equal to 1, and single shift dot get at 0. I'll do this case first. So we have to figure out what is a person that it wanted to give it to. Give it to that person, and then the original person. So who's the original person that? So if okay, wait, no. So if person I wanted to give to res as to the person single wanted to give it to, then we do some stuff where res I now gives to the single person, and we break. Yeah. I plus 1. If law is equal to n, law is equal to 0. Yeah, and so res at shift dot get at I is equal to shift dot get at law. Oh, okay. Should be 2 and then 4. Let me just try 2 test cases. 2, this is 1, 2. And then this is 2, then 2, 1. Okay, well, this should never happen anyway. Yeah, so it's kind of broken. But yeah, let's try. Okay, we got D. Okay. Problem E is next. Answer T. Yeah, E seems to be hard. Oh, E seems to be kind of hard. Yeah. Okay. Yeah, I'll potentially have to read F as well. We'll see. Prefix function of string T equals T1, T2. Tn. In position I, init is defined as the length of k of the longest proper prefix of substring t. Make sure a d can't be hacked, or like we didn't make a mistake. I don't think we did. In degrees equal to 0, then it's part of a shift. Otherwise, it's part of like the part where he fixes cycles. Yeah. We didn't get a runtime error over here. So like, I think the thing that I thought about is correct. If shift.size is at least 2, then we get to shift it over here. Otherwise, we have to do this stuff over here. Res.I is equal to single, then we break. Yeah, so like the person we wanted to give over here is this person, then we just give this person over here. Yeah. In the result count, yeah, we're just counting how many match. Okay, I think D should be okay then. Prefix function of a string, this. In position I, init is defined as length as the length k of the longest proper not equal to the whole string prefix. Length k of the longest proper not equal prefix of some substring, which is also suffix of the same substring. Wait, what? Prefix function of string? In position I, and it is defined as the length k of the longest proper prefix of the substring, which is also suffix of the same substring. Okay, I see. It's like KMP, right? 0, 0, the 1, 0, this is equal to 1. This is equal to 2. Yeah, because AB, AB. Then we have ABA, ABA. Let f of t equal to the maximum value of prefix function of string over all positions, okay? You're given a string S, reorders characters arbitrarily to get a string t. Okay, so we want to rearrange. The value of f of t must be minimized. Interesting. Out of all ways to minimize f of t, choose the one where string t is the lexicographically smallest. Okay, so we can't pick just a random string function either. How do we do this then? I wonder if we can binary search from the answer. Like, what if, for example, we wanted to make sure that this value didn't exceed 3, for example? Then we could just get frequencies of like 2 characters over here. We can't add well, I guess we could add a 3rd one, because it's proper prefix. But the next character we add has to be different. Yeah, so if we want f of x to be strictly less than, to be at most 3, or I guess strictly less than 3, whatever, same thing. Then we have like A, and then we have something like, we cannot put another A over here, so we have to put a B, or like any character in here, and then A. Yeah, because for all of these values, it's just the prefix of a previous prefix, of like the next prefix. So if we can ensure that this pattern will never repeat, then it's fine. Because like if we do A and then like B, so far the maximum prefix value of this is 2. We want it to be at most 2. And at no point should we ever have a string that looks like, okay, yeah, because we have like some suffix in here that equals to this. If we remove this character over here to get like the previous prefix value, then like the prefix is just this. It's just the same thing basically. Or it could be something else, but like it doesn't really matter. Yeah, because the thing with the prefix function is that I think it only changes by, it either goes back to 0 or it changes by, or it like increases by at most 1. Could it stay the same? Could it stay the same? Maybe. Not too sure. Is E harder than, yeah, E is easier than F. Okay. So this is the right problem to think about. Okay. Let me just make sure no one is trying to hack right now. Because if I can try to find whether there's a mistake in one of my previous things, and I want to do that right now. Okay, good. Yeah, E seems to be kind of hard. Also, there's a lot of speed forces happening. Yeah, because like it's literally just 100 points. How do we do this part? Where it's like, if we do A's and then we just throw in a B. You never want to ever have a prefix of A's equal to a thing. Okay, well, this can never be the same, so like it's whatever. A, B, A, B, A. I'm gonna try this. I think it's worth trying, at least. We have file.readline.trim.to. Because we're rearranging the string, only the frequency matters. You can only increase by at most 1, so that's why it should be binary searchable. is equal to, what is the highest possible value? I guess it's n minus 1. Yeah, it's n minus 1. So while low is not equal to high, and mid is equal to low plus high over 2. We do some stuff. Yummy. Oh, someone got H. Of course it's Rainbow. Okay. Let me just CP algorithms, KMP. The values of a prefix function can increase by at most 1. Okay. And they can stay the same. Okay, but they can only increase by most 1. So like if, yeah, okay. Like if it's possible for everything to stable x, we can use the same construction to like do the same thing. How does it work then? We use like prefix in here. Oh, but it could also be possible to do that. Like what if we have like not as many B's? Where like it's impossible to do something with an A, but it could be possible to do it with a B. I'll always minimize this. Is there any way we should go for that instead? I'll look for hacks later. Yeah, for now, I think we should still think about E. Okay, we want to first minimize the string KMP function. So what is a... Okay, if there's one character that if there's at least one character that appears exactly once in a string, it should be possible to get a string with 0. Yeah. If it's not possible, then everything occurs at most. Okay, so if there is a character that occurs exactly once, then f of string equal to 0 is possible. Otherwise, all characters appear at least twice. What if we assume each character appears? There's at least one character that appears at most twice. Then we could just put that character first. Or I guess, even if it appears like just 3 times. Yeah, if a character just appears at most 3 times. If a character appears at most 3 times, then not necessarily though. Well, I guess. Well, yeah, we could actually, because we could just have like A and then just some random stuff and then like AA. I think that should always guarantee. Yeah, because no other prefix in here will ever match until we have an A. And then we have like another A to like ensure that we have this. But if a character appears only twice in general, what if it's something stupid? Like, if there's always a way to arrange it so that this is at most 2 or something. Is there a way we can do that? If we have, like, say, A, or I guess just have, like, AA and then A, right? Like, AA and then some stuff, then A. I think it's the same effect. Oh, wait. Yeah, it's better to do this, because in here it doesn't... What if this, like, matches over here? Then it's bad. But in here, like, this can never match here. Okay, so that's how we can force that many to occur. If we can force this much to happen, then yeah, like if we can force this amount to happen, then it doesn't really matter. If we can have something that's like, what if it appears 4 times? Yeah, KMP equal to 1 is like, if everything appears at least twice, then it's going to appear somewhere else in the string. So we'll have f of 1 is equal to 1. Yeah, like in here, f of 1 is already equal to 1. Yeah, f of 1 is equal to 1. And then we do something that's like, we like have different characters. Yeah, this assumes we have different characters to like buffer with in the first place. If one character appears at most once, then it's literally just a string itself, because there's nothing else it could do. Yeah, so that makes sense. What if there's a better way to do it? Where if we can't do it with all A's, then but there's a way to do it with A's and B's. We can always do it with all A's if it was 4. We do it with A's and B's. So if we have something like AA, then B, I'm going to make sure that, or I guess, like whatever this pair is equal to. Yeah, if we do like A and then, I guess we could do like AA, and then we put like a random character. Yeah, we always do like some character is not A, then A. Always, yeah. So some random character is not A and then A. Some random character is not A and then it's A, so on. It's like AA. Wait, if a character appears at most x times, appending it x times will give a value of f of x minus 1. Okay, so upper bound on answer is the min of frequency of C minus 1. Upper bound on f of string. Yeah, because we could just like put all of the same character as that prefix. And then like no matter what we put afterwards, like it should never increase. So that's an upper bound. Is that a lower bound as well? I wonder. And here it's like min 2. Okay, so the maximum prefix we have is 2. But here the maximum value is 1. Yeah. So that's not an upper, so it's not a lower bound, but it is an upper bound. How do we make it so that it also works? If it's like A, B, and then A. Lexicographic smallest one. Maybe I should read a little bit more about prefix function. then it's like, we do A and A. Is it ever possible to have like an A, B, where it's not possible in A, but it's possible in A and B? Alright, so if we have like A, then A, and then we do like B, and then we put an A down, and B, another B down, but we can only do two A's like this. Okay, so what if we did like AB instead? We could do AB, and then it's like B, and then all of the A's. And the prefix function in here is at most oh, wait a minute. If we do A and then B, and then we put like all the B's afterwards, and we put like the rest of the A's, that guarantees a prefix function never exceeds 1. Or I guess not 1, but wait, 1 or 2? If we do A, B, B, right? Because this is 0, 0, this is 1, this is still 1, this is all the way over here is still 1. And then because we already used all the B's, we put a character here that's not equal to either, so then it resets. Yo, wait, interesting. There's an easy way to make a string such that f of string is equal to 1. Okay, let's try this. So there's like a little bit of casework. 0 is equal to false. Or int I is equal to 0, I is less than 26. Okay, I'll do outer. So if the frequency of I is equal to 1, then f of string equals 0 is equal to 0. So how do we do this? Convert I, frickin' I is equal to 0. Public static car convert in I. We return car I plus this. There we go. So while bracket A is greater than 0, sp.append convert at A. sp.append a new line, and then we continue outer. Okay. If a string appears twice, or in RC, well, no. I plus letters plus, okay, well, if, well, max of, well, I guess min of itself, of the frequency of I and 1. Yeah, so if it occurs at least once, then it's, okay, so if letters is equal to 1, and f of string is equal to n minus 1. So for each character in the original string, sp.append C Otherwise, f of string equals 1. F of string is equal to 1 now. Yeah, we do like all of the smallest characters. Or not all, but 2. Or I guess just 1. Like we do 1. No, we do 2 of them. Yeah. Yeah. If the smallest character appears, we know it's possible, but is that the best way to do it? Yeah, so we have 4 A's and 3 B's, so we do AA, then B. We could try to put a B over here and then rest our A's, and that's not a valid way. Oh, because we put 2 over here. Yeah, but we could do like AAB, and then it's like, and then we basically alternate everything. And then when it's not alternating, we just sort in increasing order. So it's like A, and then it's like B, A, B. Okay, we do the alternating case then, where it's like, how do we do this part? Okay, we know every character will occur at least twice that occurs in the string. So you want to get the first 2, append them like this, determine whether it's possible to do this or not. If it's not, then we have to do something that's like AB. Yeah, if it's possible to do this part or not, then it's like AAB, AAB, and then it's like AB, 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 C, whatever, yeah. Until we run out of A's. Check if that's possible. If that's not possible, then what do we do next? We do something that's like, obviously, we still want to try to start with an A. But it's like, that implies that this part has to start with a B. So we do a B like this. Then after we do a B, if there's a third character that exists, then we can just like do A. Because we never want AB to appear in here at all. Yeah, it's like AA or AB. Maybe we iterate over all pairs like this. Find the first one that works, maybe. Find the first one that works. So we do AB, and then it's like, if there's at least one other B, then we can't do ABA. Or a matter of fact, we can't actually put any other thing in here. If this doesn't work, then if we have AB, and we have like some other number of A's, which we have at least one more A, it would guarantee the B to end over here. Yeah, so that's not good. I think the best way we could do it in that case is if we do A and then the B, and then all the A's, and then the smallest character that's not equal to B, and then everything else is in ascending order. that's if a B doesn't exist. If a B does exist, or I guess, yeah. I feel like this is easier to, if we do this, it's easier to work with. Class letter. So public and ID, public and count. Public letter and A, B. So the ID is equal to A, count is equal to B. And so we do array list of letters. So we do this, 26. So if the frequency of I is greater than 0, ls.add frequency at, no, letter I, frequency at I. Yeah. Okay, first case is if we can put 2 of the smallest letters in a row. Okay. Actually, wait. A, B. Yeah, so we try this AA thing first, where we go like AA, then the smallest next letter, and then we just keep on alternating and see if we have room or not. So we have how do we implement this step? It's like a first letter. Okay, so it's like fill ls with frec. I feel like this might be helpful to do. Static void fill array list of letters, the frequency. Do this. Okay, so we fill. Okay, so we want to do 2 letters. New car n. Dex is equal to 2. Res is 0 equal to res at 1 is equal to convert ls.get at 0 dot dot ID, yeah. So ls dot get at 0 dot frequency or dot count minus equal to 2. Okay, so we do this part. So if I mod 3 so if ls.get at 0 dot count is equal to 0, then is fill in rest of string, and then for letter unit in ls, so while u dot count minus is greater than 0, res at I++ is equal to convert u dot id sp dot append res sp dot append this, and then we continue outer. Yeah. Otherwise, if I mod 3 is equal to 0, then, or no, if I mod 2 is equal, yeah, so it's like if I mod 2, so if it's an odd index, or I guess an even index, then we have to put a letter that's not equal to itself. Yeah, and so outer over here. No, it's like first. So if ls.size is equal to 1, then we break first. Try AB pattern. Fill in the rest of the string. If I, okay, so if this is an even index, if ls.get at 0.count is equal to 0, and then we break first. Or I guess we just break in general. Yeah, we don't actually need this part. Otherwise we continue outer. Yeah, so if it's equal to 2, yeah, this is hard to work with over here. You know what, I'm going to do this. x1503 x1530 e2. Because like I think I know how to do it. It's just the way I'm implementing it is kind of messy. So I'm going to restart this section over here. F of string is equal to 1. Yeah, like this part is all kind of messy. 1530 e2. Okay, so we want to int first is equal to, yeah, I is less than 26, I plus plus, and so if the frequency of I is greater than 0, then first is equal to I, then we break. And second is equal to I plus 1. Or no, first plus 1. Okay, so car res is equal to new car at n. Res at 0 is equal to res at 1, which is equal to convert first. The frequency of first minus equal to 2. Because we know that if first occurred once, then we could force a string to have this equal to 0. We continue outer. Yeah. I is less than n, I plus plus, and so while frequency at second is equal to 0, or I guess while second is less than 26, and this. Yeah. So if I mod 2 is equal to 0, well, hold on. The first thing we check to see if the frequency of first is equal to 0. If it is, then that's great, because then we could do this part over here. We just do while second is less than so while frequency at a, then it's like res at I++ becomes convert at A. And then after all the step is done, it like doesn't matter what we do then. Yeah. We just do sp.append res, sp.append a new line, and then we continue in order. Okay, otherwise, if we need to put another letter, so if second is equal to 26 and we break. So works1 is equal to true. Works1 is equal to false, then we break. Otherwise, we do what do we do over here? We do res at I is equal to convert at second, and then the frequency of second decreases by 1. Else, we just do res at I is equal to convert at first, frequency at first decreases by this much. Yeah. So if works1, then we can just do this. Okay, so this is like the first way we can do it. Okay, so AB yeah, it's like A then B. So if we, okay, well if the number of letters is equal to 2, then we do one thing, otherwise we do something else. Okay, because we have to, okay, we have to reset frequency. Reset variables, we do this. Reset frequencies. If letters is equal to 2, then there's at most 2 different letters. Then it's just like, yeah, otherwise we could do like AB, put all the A's in, put the third smallest letter, and then everything else in increasing order. So print C is equal to 0, C is less than 26 equals plus. If frequency at C is greater than 0, first is equal to C, then we break. Yeah, we reuse first. Second is equal to first plus 1. Or int, no. Okay, so while second is less than 26 and frequency at second is equal to 0, second plus plus. And so, what we do is sp.append convert at first, and then while the frequency at second, sp.append at second, and then while frequency at first, convert at first, convert at second, convert at first, and this is 1. sp.append here, and then we continue. Oh no, we just do this part, and that's the end. Otherwise, we still find first and second. Yeah, this is still like a thing. So in third now becomes, so while third is less than 26 and frequency at third is equal to 0, third plus plus. And so what happens now is that we do convert at first, convert at second, and then we do while frequency at first is greater than 1, convert at first, convert at third. frequency a second minus minus, frequency a third minus minus, and then we do third, and then second is already decreased by 1, and then we just fill in everything else in order. So while frequency at C minus minus SP of 10 convert at C. Okay. Does it work for samples? It works for samples. I'm going to create a few test cases to screw around with this. Okay, so if we have something that's like 1, Z, everything else appears over here. D appears at most once, and it's the smallest character that appears at most once. Yeah. Okay. We already have the ZZ thing. I'm gonna do 1. What if I just do XXXX, H, XX? What if we do this? Like, what if I do like 2 different things, where the first thing is XXXX, EEX. Second thing is this. EXEEEE. Yeah, because it's the first character. Yeah, okay. I'm gonna submit this, see what happens. We got E. Okay. We have solved problem E. That's nice. We also managed to not have any wrong submissions. That's nice. Okay, do we try to solve F, or do we just try to hack people? Let's see. Do we try to solve F? F seems kind of hard. I wonder how standing's looking here. All of them have gotten that. We'll figure it out. Anything with a hacked verdict yet? Nothing. Okay. Bingo. Is a, oh wait, there's like decimal stuff. Output mod this. N rows and N columns, and you fill each cell in the table with some event related with a festival that could either happen or not. For example, whether you win a prize at a festival or whether it rains. Forecasting algorithms using behavior estimated probability for each event to happen. Event in row I and column J will happen with probability this. All these events are independent. It's called table winning. There exists a line such that all events in it happen. The line could be any horizontal, any vertical, the main diagonal, or like the longest diagonals. Such that there exists a line. Okay, so it should be easier to count to figure out the probability such that none of these occurrences happen. Is 31607 prime? The largest prime less than the square root of 10 to the 9. I guess they're all pretest too. What if we just like do a mask where for each, if we think about it in terms of columns, it's like we have some mask of these events that can occur. And then out of all of those masks, what is 3 to the power? Is 3 to the power of 20 big? Or 3 to the power of 21? It's too big. Yeah, I'm not sure how to do it then. I don't think so. Maybe I just try to hack people now. I don't want to try hacking people until someone else has gotten a hack yet. Let me just look over all my problems. Okay, well this is while n is greater than 0. Yeah. That should be fine. This one's just greedy. I'll be surprised if that's not correct. This should be fine because I proved it. Yeah, I proved the upper bound and like went a little over just to be safe. So it should be okay. Am I doing any object comparison in here? I'm not. No, just this integer, or just an int. Okay. Problem D. I'm kind of scared about this one. This one I'm kind of scared about. I think E should be fine. Like, if it got through, because it's multi-test, I feel like all of these cases should have been covered. I'm not too worried about that. Let me just make sure I use convert everywhere that I needed to. Convert, convert. And it says a character itself, it's fine. Convert. Convert, convert. I wonder if this is okay. Let me just make sure. I want to try to write a case that forces us to everything occurs at least twice. Yeah, okay, it's fine. Good, good, good. If I and 1 is equal to 0, there's like this 2-pointer thing that happens over here. If second is equal to 26, yeah. Yeah, E is probably fine. I do need to make sure my D is correct. Because I didn't really prove D. But wait, were there multi-tests? Okay, there were. How many pre-tests were there? 8. It's probably fine, I guess, then. If there's that many tests. Okay, then make sure we don't do any, like, object comparison. I don't see any. Yeah, I think we might be fine. I think we just might be fine. If I can somehow get hacks, that's going to help my rank a lot. Actually, what is my delta right now? See if it updated or not. 68. Not 69, sad. I'll just go through everyone. Who else? Oh. Cool, cool. Someone got G. Who? Okay. Pretest 2, pretest 2. Pretest 2, pretest 2, pretest 2. They're all pretest 2. I mean, at least in here. What was C? Oh, okay. Okay, I think A is the safest one to lock. While n is greater than 0, yes, we just find like the largest digit. Like if we do something that's like 2, it could be 1 and 9, yeah. I want to lock A. All right, we're going to start hacking, or at least try to hack for a little bit. I don't know if I can actually find anything or not. Let's see if there's anyone that's been hacked yet. Nope. Well, I'll try my best to find something anyway. How many solves are there? F? There's like what? 48. I guess it's actually not. I mean, it's 2 hours and it's that many. I don't know if I could be. Because, like, for every mask, I guess, yeah, like, what is the probability for some, yeah, if we have, like, some set of items that happened, and then it's, like, another set of items, another set of items, obviously you can't equal to the entire mask. And you also have to maintain whether or not it's equal to the diagonal or not, from where it currently is. Like, which diagonal could it be equal to? And we'll make sure none of the diagonals are working. So it's like we do this, and then from every mask in here, we want to find a way to transition to the next mask. I guess the only number of ways that matters is for each mask, how many are within the submask? We have some items in here that happened. We go to the next row. Only items can only like decrease after that. But even then, it's like for each way, it's like 3 to the power of that for all of the transitions. Because it's like submass, right? It's like 3 to the power of 21 at least, and that's just already way too big. Okay, I have to turn off dark mode to see the code properly. Okay, I'm gonna minimize this tab over here so that you guys can see this. Is this good? Yeah, that's good. Temp. Yeah, that's fine. I have a feeling with problem A, it's just hard to input that 2-card array. Is there any way I can force a time limit on this? That's a really cheesy hack, but I wonder if it's possible or not. Ah, shoot. Let me just move. Okay, I wanna move my I'm gonna move IntelliJ over here because I'm probably only going to use it to write like script, like ways to generate a test. So it's not going to be super interesting. X1530A hack. X1530A hack. What is the maximum number of test cases? How big is it? Oh, it's only 1,000. Okay. If it's only 1,000, it's probably fine. Yeah, if it was like 10 to the 5, I might have been able to like get it because it's like a tight time limit. But like even in the worst case scenario, you're only like converting 9 times. Yeah, there's no way this doesn't work. This works. There's no way it doesn't work. In rem and 1 equal to 10. Yeah, that's fine. Func n, while n is greater than 0, the max digit is equal to 9, then we return 9, okay? Can n equal to 0? No, it can't. Okay. Int min. Yeah, this is fine. Max c equals -1, while n. Yeah, that's fine. I think the A is like a type of problem where like it's just hard to write. It's hard to write an incorrect solution that passes a lot of cases. Yeah, so I'm probably not going to be able to hack A. max I equals max I s at I at 0. Yeah, that's fine. Wait, what is going on here? Long int p is equal to this, while a is greater than 0. Int a is equal to n. Oh, you're using, okay. And a is equal to n over p. Oh, okay, I see. That's probably fine. Yeah. It's probably okay. Yeah, I have a feeling all of these will be fine. Might be able to get some hacks in B though, if people are doing like some sketchy stuff in there. Max element minus 0, yeah, that's fine. Any hacks yet? None. If you're curious, these are my friends, like people on my friends list. TLE pretest 7. How many pretests are there for F? 14. Yeah, whatever. I don't know. Maybe not. No. Click the reset. I want to look at TLE verdicts. 7, 7, 7, 10. Yeah. I guess those are just like when the bigger cases happen. This is fine. That's fine. That's okay. Yeah, max digit. Yeah. Okay, A looks. Do I try to hack B? Is my B okay? I mean, these are all the directions. No, I don't think it matters too much. Min dx cdy rdx plus cdy cdyd is less than m. If this and this and this and this, if sum is equal to 0, then we set it equal to that. lock B. I didn't want to lock. Okay, just like, let's just assume. What if somehow my B gets hacked? How many places would I drop? I would drop to like about here. But like, I think a better question to ask is, if my B gets hacked now, what would I do to fix it? Honestly, I don't know. Because I'm starting from the corner, right? As long as you're starting from a corner, the corner is always the first best possible move. And then from there, you just like create another corner, right? What is the size of n? It's at least 3. Okay. So like there's a defined border always. Yeah. I wanna lock B. Because I think it might be easier to get a hack on B. I don't want to hack D, because like I'm not super confident in that. I mean, okay, I'm like pretty sure my way is correct at least, but there could definitely be. I wouldn't be surprised if it got hacked. Any hacks yet? None. I start with you. Wow, that looks annoying. Am I gonna create like a way to hack B? Dx dy static int dx. I guess I should just copy all of this. Actually, wait, no. Let me just delete a hack. X1530 B hack. I shouldn't do this. I'll just put hack over here. Yeah, I guess the only things that matter are what is the limit on B? It's 100 test cases. If there's 100 test cases and there's at most like 17 times 17 options in the first place, or I guess 18 times 18, what is that? 324. Oh, all of them would be covered anyway, I guess, right? Or I guess most of them. Yeah, it would be hard to imagine how I could hack B. Yeah, I didn't realize, like, because of how small the bounds are, it's likely that the pretests pretty much have all possible inputs anyway. Yeah, I'll scan through just to see if anyone's doing like anything blatantly dumb. But I don't think they will. Like if it works for sample input, it's probably correct. Like if it works for, you know, like 133, yeah, even. If we do this, okay, set everything to 0. We set this equal to 1, and then we set the reflection to be equal to 1 itself. And the reflection, yeah. I don't think there's an issue with that. You're attempting G. How many solves are on the rest of the problems? 66, 2, and 3. Should I just focus on writing in? The diagonals just seem like an annoying detail. Oh, if we can find the probability that none of these happen. What if we do meet in the middle? Like meet in the middle and like subset of SOSDP. Or I guess just SOSDP in general, maybe. Yeah, because we could find that for every math. About 2 more minutes. So we have this 7-second time limit. Each row we have. Okay, wait, if the diagonal condition doesn't exist, then no. Yeah. So what if we do something that's like, yeah, that just seems annoying. Yeah, this just seems like an annoying thing to implement. Not sure. Yeah, E ended up being pretty easy, I guess. Yeah, because like the interesting thing about E is that I actually don't know how KMP works, because so like I've never actually used it before, but like you don't actually need to know KMP to solve E. Any hacks whatsoever? I'll look through the rest of these. That looks annoying, but it's probably fine. I think I'm just going to look for like, if anyone has like an edge, they like handle an edge case incorrectly or something. What are our predicted ratings? That's sad. It's so sad. Oh my god. Almost LGM. Smooch. Uh, okay, that's fine. Sad. Literally no hacks going on, which is a good thing, but it also means I can't get points. Okay, I think I'm actually going to stop the screencast here. You know, like, yeah, if I like get any hacks or get hacked, hopefully not, then I'll just mention it in the comments or the description. But yeah, other than that, I hope you enjoyed. I hope you enjoyed watching me compete today. And if you competed today, then hopefully you did well as well. Nice. Okay, how do I turn this off?